All right, here we are. We're back for part 2 of this. So I need to decide what's going to happen next. So I need to construct a m over EI integrand that goes this way, which is great, but I got this change here. So what I'm going to have to do, I'll have to choke up on the page here a little bit. So I will now integrate from 6 to 12. And what do I integrate? Well, I have a second moment equation, which you remember is over here. So my real moment now will be minus 0.6 20 minus x squared. And what's my virtual moment? Still the same, x minus 20. And that is also divided by E over 2EI. And then the last 8 feet, which will be an integral from 12 to 20, I have my second half of my real moment equation, and I have the same virtual moment, but this time I messed something up here. This needs to be another one there. Yeah, this will just be times EI dx. So this is where I'm going to stop, I think, because I have a feeling that without enough time and enough coffee, that I will probably make a mistake here online. I mean, live, like we're doing it now. Well, the easiest way to do it is going to be to expand this, and it will end up being, this will be a cubic function, this will be a cubic function, this will be a cubic function. Now, one thing about this is these two are the same. The numerators are the same. The only difference is 2I and I. It'd be very easy in MATLAB. The only problem with that is you can't use MATLAB during the exam. So I would suggest that you do it by hand and check it with MATLAB. How about that? I'm pretty sure if I did it up here, I would probably make a mistake.
What makes you think a week one?
Well, I mean, I just given the time and, I don't have scratch paper.
So we'll
probably mess something up.
Most likely we'll have a easier one for the test where we can integrate.
Not necessarily.
Pretty fast.
That'd be hard.
Without messing up.
No, the integration will not be difficult. You'll see that if you get this expansion right, then this is a fairly easy polynomial to integrate, but you do have to evaluate at 2 limits. So these will be the more challenging and tedious ones.
Can we choose to veto this if we don't have enough time to copy the links over?
No. So there is another option would be to, and I've done this in the past, is I ask you to develop the virtual work equations, but I don't ask you to solve them. So this would be the answer if I asked you to do it that way. And if you had time, I might even offer you a bonus if you would then complete the integrations, put in the values, and solve for it. But I would encourage you to save that to the very end. Right? Set these up, work the rest of the problem. If you look at your watch and you have 5 or 10 minutes left over, then circle back and do it. Don't try to pick up the measly bonus and not answer a 25-point question. Well, what I'm saying is this might be the answer to the problem. You're done. As far as you've done the hard work here, the rest, in reality, is a simple MATLAB problem.
We gotta remember how to do MATLAB too.
What's that?
You have to remember how to do MATLAB.
It's not that hard. In MATLAB, all you have to find is x as a symbol and write these equations just the way they are. And MATLAB has a very simple function called int for integration. And you'd say integrate this function, comma x, comma 0 to 6, 6 to 12, 12 to 20. It's pretty simple. In fact, what I may do is I'll write the little M code and I'll email it to you if you want to see how to do it. And that would be a great thing to have at home. It's not a great thing at home because you have to use the UMware, which no one's listening, is atrocious and they should get rid of immediately. It's a complete waste of time and energy.
The what?
UMware.
Well, that's what we had to do last.
I know. I have to turn this off to tell you what I think of UMware, so it won't be recorded.
What's wrong with it? So is there a new way to...
Okay, let's just stop this here, and I'll end the video, and we'll talk about it later. Thank you.
That's what we had to use last.